and people who are on boats. If you sail off into the sunset, you can just continue to sail, or you will hit land at some point, but you don't run into a singularity, thank goodness. Not yet, anyways, not that we know of. I know because I've been around the world. Stephen Hawking says. Stephen Hawking has gone around the world, and so he knows that you can indeed go around, all the way around. Thank you, Toothless. How are you? If Euclidean space-time stretches back to infinite imaginary time, so because in quantum, in the Feynman sum over history's way, in the quantum way, we allow for infinite imaginary time, right? We allow for infinite imaginary time. So if Euclidean space-time stretches back to infinite imaginary time, thank you for liking the live. Thank you so much. Can we get 20 likes? And thank you for the hearts. If Euclidean space-time stretches back to infinite imaginary time, or else starts at a singularity in imaginary time, we have the same problem as in the classical theory of specifying the initial state of the universe. God may know how the universe began, but we cannot give any particular reason for thinking it began one way rather than another. On the other hand, the quantum theory of gravity has opened up a new possibility in which there would be no boundary to space-time, and so there would be no need to specify the behavior at the boundary. There would be no singularities at which the laws of science broke down, and no edge of space-time at which one would have to appeal to God or some new law to set the boundary conditions for space-time. One could say the boundary condition of the universe is that it has no boundary. How to PhD? Yes, Mexi Ghost Hunter. Did you find my blog? So the boundary condition of the universe is that it has no boundary. Aw. Oh my goodness. Well, Toothless has asked a very important question. Why do you not just give up? Let me come back to that question in just a little bit, okay? Thank you so much for being here, and thank you for asking that. The boundary condition of the universe is that it has no boundary. The universe would be completely self-contained and not affected by anything outside itself. It would neither be created nor destroyed. It would just be. I kind of resonate with that, actually. I like to just be. I don't like to be created or destroyed. Not any more than I already have. I just like to be. I like being with the universe. Let's continue to be. Oh, thank you. Did you send again? Oh, or you tried to? Thank you so much. It was at the conference in the Vatican mentioned earlier that I first put forward the suggestion that maybe time and space together formed a surface that was finite in size but did not have any boundary or edge. My paper was rather mathematical, however, so its implications for the role of God in the creation of the universe were not generally recognized at the time, just as well for me. At the time of the Vatican Conference, I did not know how to use the no boundary idea to make predictions about the universe. So Stephen Hawking had gone to this conference in the Vatican. However, I spent the following summer at the University of California, Santa Barbara. There, a friend and colleague of mine, Jim Hartle, worked out with me what conditions the universe must satisfy if space-time had no boundary. When I returned to Cambridge, I continued this work with two of my research students, Julian Luttrell and Jonathan Halliwell. Not everybody creates children, the new ones anyways. But some people do, some people don't. Thank you for that question as well. So I'd like to emphasize that this idea that time and space should be